We're going to try to figure out how we can find volumes of three-dimensional figures. And if it's not a nice geometric one that we've learned in the past, what about things that have kind of curves to it? So our method is we're going to try to come up with some slices. So if we can come up with slices, we can get a rough idea of kind of find the volume of this slice. And then we have a whole bunch of them and something like this. And we can add all those volumes together, but it gives us an approximation. So we do have a summation going on, and we're going to find a bunch of different areas. We're going to be adding a bunch of these little slice areas together, these smaller volumes. But we want to be as precise as possible. So to be more precise, we have to cut more slices and more slices. And so eventually we're going to turn this limit. This limit is we're going to go and have an infinite amount of slices. But what happens is your width, which is your delta x, ends up being infinitely small. So an infinite amount of slices with an infinitely narrow slice. So that all that basically becomes is an integral. So as the number of slices increases, the thickness of each slice goes to 0. And so our volume obtained is going to become a definite integral. Right? So if you notice the formula is we're going to be finding an area formula, and we're going to do an integral of that area formula. Right? That's the key. So let's do an example. And our example is going to be this one right here. So we're going to let R be the region of the first quadrant bounded by the coordinate axes, so the x and y axes, by this curve right here. So this quadratic that's going down. It says a solid has a base R, and the cross sections through the solid perpendicular to the base and parallel to the y-axis are squares. So we're going to try to figure out what is it that they're talking about. We're going to find this volume. So let me do a two-dimensional version of this, trying to make some sense. So we have a quadratic that has a height of 1, and it's going down. And so if we are at 1, we would have a curve associated with this. All right, and so that equation would be 1 minus x squared. It would also hit at 1. And so what we're creating is this height right here, which is this height is dictated about this equation. It depends on how far out you are on the x is going to give you a different height. But basically, it creates a three-dimensional square, and we're going to find that area right there. So it's creating this. And so when we start off with small x's, we're going to have the bigger y's. And as the x's are increasing, our squares are going to become smaller and smaller and smaller. Right? So that's kind of the three-dimensional look to it. So what we need to figure out is we're going to be doing the volume is going to be the integral of the area. Well, we need an area formula. That's the key. So our area formula is how do we create these rectangle or these squares? So these squares are going to be this height right here is dictated on this. And so you're creating squares. And this height is going to be a 1 minus x squared. But since it's a square, then the width is also going to be 1 minus x squared. And so our area is going to be 1 minus x squared times another 1 minus x squared, giving us a 1 minus x squared squared. All right, so that's our area formula. That's what we're going to do the integral of. So our volume is going to be xy's, we're going from a 0 to a 1, 0 to 1, and our area formula is 1 minus x squared squared, because it's length times width. All right, so for the math on this, I am going to go ahead and multiply this out because I think that's going to be a little bit easier. So we're going to go from 0 to 1, and if we multiply this out, we'd have a 1 minus 2x squared plus x to the 4th dx. And let's do the antiderivative. So if we add a power, we're going to turn it into an x minus 2x cubed over 3 plus x to the 5th over 5 from 0 to 1. So if we plug in 1, we have 1 minus 2 times 1 cubed over 3 plus 1 to the 5th over 5. And then if we plug in 0 into this, we would just be subtracting 0. So this turns into a 1 minus 2/3 plus 1/5. Let's make these all common denominators. So this is going to be a 15 15ths because the 3 and the 5 can become 15. So we multiply by 5. That's a 10 15ths plus a 3 15ths. And if we add that together, we got a 15 minus 10 is a 5. 5 plus 3 is going to get us a volume of 8 15ths, whatever the unit measurement would be. So units cubed. All right, so that is how we find it. The key is figuring out what is our area that we are talking about. And that was based on this height was based on this equation. And that height, because it was a square, was going to have the exact same width to it. And so there's our area formula. And then we do the calc to figure out your volume.